Hi all. In the last video, we saw some of the problems which was under drain current equation. So now we will see two more problems in this session. So read the question carefully. When when a reverse gate voltage of 15 volt is applied to a JFET, the gate current is 10 to the power minus 3 mu A. Okay. Find the resistance between gate and source. So here you know that they have asked you to find the gate to source resistance value. So it means VGS by IG is asked. Okay. So VGS, which is already in the problem, that is 15 divided by IG is 10 to the power minus 3. Okay. Into micrometer is there, no? So 10 to the power minus 6. So I will be considering this as 15 by 10 to the power minus 9. So this I can write it like 15 into 10 to the power 9. Okay. So my final answer will be 15,000 meha ohm. Okay. So now we have to have a note in this, because in our BJT, as everybody know, BJT has very low impedance value. Okay, so the impedance value will be like in hundreds or in thousands. Okay, but whereas in our JFET we will be having very high impedance. Okay, so this particular answer helps you in finding out the difference between the impedance which is very low in BJT and the impedance which is very high in JFET. Okay, so now we'll move on to the next question. So here you can see the following readings were obtained experimentally from a JFET. Okay, so you can see that the VGS, first it is like 0 volt, then again remains the 0 volt. When the volt is given like minus 0.2 volt, my VDS will be like 7, it will be increasing to 15, and a steady state 15 volt will be maintaining. And when these things happens, my ID current will be 10 milliamps. It increases to 10.25 milliamps, and again it decreases to 9.65 milliamps. So this was the readings obtained by doing experimentally. So now with the help of these values, we are going to find AC drain resistance, transconductance, and amplification factor. So the first thing which we are going to find is AC drain resistance. So AC drain resistance means, to find this we require the change in, okay, we require what we need. We need our drain source voltage value, but you can see there is a change in VDS, no? I mean, yes. So what I'm going to do, I'm going to put it like change in drain to source voltage. Drain to source voltage. So I will be getting it like, okay, del VDS. Del implies that the value is then changing. Okay, so that is my 15. You can see 15 to 7. It is changing, no? So 15 minus 7, I will be getting the answer as 8 volt. Okay, and similarly, my drain current is also changing. So I'm going to put change in drain current ID. So that is, you can tell it like del ID. So del ID is equal to, what is the change? 10.25 minus 10. So that is equal to 0.25 milliamps. Okay. So now I'm going to find my AC drain resistance. The formula of AC drain resistance is RD is equal to del VDS by del ID. Okay. So when I substitute this value, that is 8 divided by 0.25, I will be getting 32 kilo ohm. Okay, check it, 32 kilo ohm. So I finished finding my AC drain resistance. Now I'm moving on to transconductance. Okay, so transconductance means, as everybody know, transconductance notation is GM. Okay, so GM is equal to, what is GM value, ma? So here you can see with VDS constant at 15 volt, drain current is changing from 10.25 milliamps to 9.65 milliamps, as VGS is changed from 0 to minus 0.2 volt. Okay, so here my del VGS, del VGS is equal to 0.2 minus 0. So that is going to be 0.2 volt. Okay. And my del ID is equal to, so it is here, it is reducing from 10.25 to 9.65. So I'll be getting the answer as 0.6 milliamps. So now I'm going to substitute these two values in my GM, where my GM formula is del ID by del VGS. So that is equal to 0.6 divided by 0.2. So when I substitute this, I will be getting the value as something around 3000 micromole. Okay, micromole. So micromole means this is the unit of transconductance. Okay, so now we finished finding the transconductance also. And the last thing is amplification factor. So amplification factor, it is actually very easy. So amplification factor formula is mu equal to RD into GM. So now we have our RD value and we have our GM value. Okay, so just I'm going to multiply. So if I put what I'll be getting, my RD value is 32 into 10 to the power 3 kilo ohm, right? 10 to the power 3 into, and my GM value is 3000. I'll put it down, 3000 what? Micromole, that is into 10 to the power minus 6. So when I calculate this, I will be getting my answer as 96. So this will be my amplification factor. So according to the readings given, we finished finding AC drain resistance, transconductance and amplification factor. Okay. If you have any doubts, please put it in the comment section. Thank you.